Okay, a quick video on implicit differentiation. I want to talk really quickly about why we might use implicit differentiation. So I use this circle as an example, and this is the circle given by the equation x squared plus y squared is equal to 64. And what I'm saying, I chose that x is 7, and what I said was that there's the point right here where x is 7, and there's its tangent line, and it has a specific slope. But if I go straight up, x is still 7, and it has this point, and it has a tangent line that has a different slope. So with implicit differentiation, we're saying that we're aware that to find the slope of this equation, we need its x value and y value. It's dependent on both of those things. So here I'm going to find dy dx of x squared plus y squared is equal to 64. So let me just write this out. I'm telling you that I am going to take the derivative ddx of x squared plus y squared is equal to 64. So I'm saying that I'm going to take ddx of x squared, which we happen to know, plus ddx of y squared, and also ddx of 64. Some of this stuff we know. We know that the derivative of x squared is 2x, don't we? We also know that the derivative of a constant is equal to 0. This is where it gets a little trickier, though. So here we're going to act like this is the chain rule. So what I'm saying is this: when we use the chain rule, we take the derivative of the outside times the derivative of the inside, right? So I'm looking at this function like this. So in yellow I have the outside function. Well, the derivative of the outside function is 2y to the first power, isn't it? I just rewrote this. But now I have to take the derivative of the inside. And what is the derivative of y? Well, the derivative of y with respect to x is the derivative of y with respect to x, right? So now remember, what we want here is we just want to know, it says here that we're to find dy dx. So I'm going to start doing some algebra. I'm going to subtract 2x from both sides, and I'm going to get 2y dy dx is equal to negative 2x, isn't it? I'm going to treat this 2y as if it was a coefficient. I'm going to divide both sides by 2y. I'm going to get dy dx, which is what we're looking for. The derivative of y with respect to x is 2 times the x value over 2 times the y value. All right? And of course, this can simplify to x over y. And if you look at that, it makes perfect sense, because here we see that the derivative here, the slope here of this equation is positive, but the slope at this other x value is negative. So we'd have to be able to sort that all out, wouldn't we? Okay. Hope this was really helpful. If you haven't already subscribed, please do. Your comments are always welcome. And this one's for you, buddy. All right.